Hello and welcome back to class number 4 of moc103, an introduction to Mocha Pro. This is our rotor from last class, and as I promised in this class, I want us to take a closer look at how to get your rotor out of Mocha in a way that best suits your workflow. Basically, there are two main approaches. You can render out images as a file sequence, or you can export metadata that suits your host application. So these might be shapes for After Effects, nuke rotor shapes, flame G masks, you name it. Each of these have their own potential advantages and limitations in comparison to a rendered image sequence, and as the aforementioned applications, After Effects, Nuke and Flame, are not only industry standards, but also the tools most heavily used here on FXPhD, we are going to explore the workflow for all three of those. Before we do that though, I want us to take a look at two features which are really important for rotor work, but which I intentionally neglected the last time: edge softness and motion blur. My reasoning is the following. Everything I showed you in the last class is universally applicable, whether you're rotoring in Mocha AE or Mocha Pro, whether you want to export rendered images or metadata. But these two features don't translate too well in every workflow, so I thought it would be more appropriate to discuss them in this class. So let's start with edge softness. So I'm gonna start by switching off the occlusion on my image so that we see the whole picture. I'm gonna zoom in here on my tire. And if I want to set up the edge softness for a specific point, I can select that here, like so, and just hit edge width set. And now you see the handle change a little bit. And also, if we zoom in really close, you'll see that in addition to our pink outline here, we've got another blue line. So this distance between those two is defining the edge softness. And of course, we can increase or decrease that by pulling on the handle here and holding down Alt at the same time. So that way, I can pull out that softness like that. And if we switch to a matte view, there you can see that softness. If you want to set up edge softness for the whole shape, you can do that of course as well. Just make a multi-selection on all your points, hit set, and then you'll get a soft edge. And of course you can still adjust individual points. Just select one, hold on Alt, and pick that handle, and that way you can modify your edge softness on each handle individually. So you'll find the motion blur in the similar area as the edge width right down here, and it behaves in a similar manner in that regard that you have to set it up shape by shape. You don't have a global motion blur inside of Mocha. So if we zoom in here just a little bit, and let's set up an occlusion view with a matte overlay like that. So if we switch this on, we should be able to see it, but we don't. This is a little bit peculiar. You actually have to select the shape you want to view your motion blur on. So this is the matte for the tire. So we have to select that. And there in RGB view, we can actually see it, but we can't see it in the pre-comp, which is a little bit annoying because this is where you could actually really set this up nicely. So in regards to values, you can increase or decrease the motion blur with a shutter angle. So if we pull that up, we'll get more motion blur. With a face, I can adjust the orientation of the motion blur, whether it travels behind the shape or in front of it, like that. And the quality slider is pretty much self-explanatory. So if I increase this, I'll get a finer sampling on that edge. With all that being said, the motion blur quite heavily influences your render time, like in every application, but especially in regards to Mocha, applying a lot of motion blur can really bog down your render times. So to set up a proper output render for this, I'm gonna quickly set up motion blur for all these shapes and be back with you in a second. So here we are, I set that up. What's a little bit cumbersome is that you can't really bulk select these. If I do that and switch, for example, now motion blur off on these, and if I take a look there, it's still on all except the very first layer I selected. So be aware of that. You can't bulk select these. You really have to manually switch those on and off. But I've gone through these one by one. So as you can see, if we go, for example, to the right arm, it's got motion blur applied now, as well as, for example, the right mirror. So we're all set. Let's get back to our RGB view. So I'm gonna go up here to the selected layer, and there we are. And now let's take a look at how to export our roto. So for starters, let's just assume that your supervisor just wants you to export the whole roto of the driver and the bike into a single alpha channel. So let's do that. For that, go up to the menu here, and you've got now the option to export a rendered clip and rendered shapes. And in my experience, rendered shapes offers much more flexibility. So choose that, and a pop-up menu will appear and give you a couple of options where to export and what to export. So let's take a look. So by default, Mocha would just export the selected shape. That's not what we want, because then we would just get this little part of the bike here. What we want is all visible, because I turned off all my track shapes. I don't want those exported, because as you remember from last class, those overlap in some cases and are not really there for the roto itself. They are just assistant shapes to generate tracking data for our roto. So we want all visible. And as we said, this is the basic example. We'll go with a grayscale matte. And we're going to specify an output for that. So now we're in class number 4. Open. And we can choose a file format and a prefix, which will in essence be our file name. By default, this is derived from the selected meta name, but we'll name this driver and bike. And we'll start with an index of 4. We've got 149 frames. So I think we're good with 4 indices. We don't want to export a QuickTime movie. I'm fine with a TIFF sequence. So let's go. So Mocha is now gonna save that clip, which in Mocha speak basically means it's gonna render that clip. So as you can see with the progress bar here, this might take some time. So I'm gonna speed that up and see you in a bit. So I quickly loaded the result of our render into Nuke just to see what's going on. So that looks all nice. One thing to notice though about this TIFF sequence we just rendered, it just contains one channel, and by default an application like Nuke would identify it as the red channel. So as you can see with the red chip down here, we just got one channel in this TIFF. So if I would, for example, call up the green channel or the blue channel of that picture, that's just empty. Also the alpha channel is empty. We just got it in the red channel. So you would need to pipe that into the alpha channel in any application you would like to use this in. The next scenario I want to tackle is what we need to do in order to export just the bike without the driver. So that sounds easy, but remember we've got the front of the bike, then we've got the driver, and behind him also parts of the bike. So how can we go about that? Well, one thing I didn't show you yet is that you actually can set individual shapes to either add to the mat or subtract from the mat. So let's jump to a position where I can illustrate this a little bit better. Maybe around here where his leg occludes part of the exhaust pipe. So let's go zoom in a little bit and select that shape. And here under blend mode, you can change this to subtract. So that way that mat now gets subtracted from everything below it. That's why the layer order is so important, that we got the front of the bike on top, then the driver, and then the back of the bike. So now let's just quickly change all those to a subtract. So if you would now repeat the procedure, you would get an image sequence where you've got a mat of the bike with the occlusions from the driver. However, there's a smarter and maybe more flexible way to set this up. So I'm gonna undo that and just set everything back to an add. And instead, we're gonna make use of the fill color of our layer. So far, we only used white, but actually, as I illustrated to you in Nuke a couple of seconds ago, we can utilize the R, G, and B channel of our file sequence. And as we've got three parts of our mat, the back of the bike, the front of the bike, and the driver itself, we can assign each part of our mat to a different channel. So how do we do that? That's pretty easy. We can actually change the fill color right here next to the outline color. And what's really neat, we can bulk change that per folder. So let's choose red for the front of the bike. And I'm gonna choose the RGB sliders in the pop-down menu here and just pull that to a full red. I'll select the fill color of the driver and choose a solid green, like that. And then for the back of the bike, I'm gonna choose a solid blue. And now I'm gonna once again bring up the export rendered shapes dialog, but instead of choosing grayscale on the colorize output, we're gonna select by matte color. Of course, we're gonna once again select all visible. I'm gonna keep it in the same directory. I'm still gonna use a TIFF sequence. I'm gonna name this driver bike puzzle mat. And once again, I'm gonna set up an index of 4 and render this and be back with you in a second. So once again, I loaded this up in Nuke, and this is the result, just like we specified it. Red for the front of the bike, blue for the back of the bike, and green for the driver. So what can we do with this now? Well, let me emphasize that this is nothing Nuke specific, that you can do this in any app. In Nuke, you would use something like the shuffle node. So let's bring that up. And what that allows you to do is basically assign each channel to any other channel. So in this little matrix here, we can define that the red channel should, for example, go to every output, including the alpha channel. And we'll name this bike front. And then I'll get this as a result. And if we take a look at the alpha channel, then it looks exactly the same. So now I can easily use that as a mask. I'll quickly set that up for the other two ones as well. So another shuffle node, and that will be the driver. And I'm gonna pipe the green channel to everything, including the alpha channel. Hook that up here. And last but not least, the back of the bike, which is in the blue channel. I'm gonna hook that up here, here, and of course, most importantly there. And that's the bike back. So now I've got my bike front, my driver, and my bike back. And now I can use, for example, these as color correction mats. So if, for example, we want to make the front of the bike pop a little bit more, we can hook up a grade node and utilize this here. And give this a little bit more of a pop. And then we can use another color correction on our driver. Maybe we want to gamma him up a little bit. Let's take a look at that. So basically you get the idea how these puzzle mats are supposed to work. And as I said before, You can set this up in any application, but this is a really neat way because you save a lot of render time and a lot of setup time setting up different passes for different renders, instead utilizing the 3 channels that RGB has to offer to you. So if you're running the plugin version of Mocha Pro, you've got another way to output your mats. In this example, I'm running Flame, but apart from the positioning of the buttons, everything is pretty much the same throughout any application, whether you're using After Effects, Nuke, Resolve, you name it. What you want to do to output a mat out of the plugin is to hit this View Mat button. It'll take a moment to initialize, and then our mat appears. And if we zoom in here really closely, you can see that even our motion blur is rendered correctly. That is because not the engine of the host application is rendering the shapes, but rather the Mocha engine. That is why it took a moment to initialize. What you can also do from this interface is call up this visible layer pop-up. And there you see every layer that you created inside of Mocha. So if we dive in here into the driver, for example, you can see all our track shapes, all our mat shapes. So you can even switch off parts of your mat. You just have to confirm that by OK. And then after a moment, you'll actually see the mat without the driver. There are only 2 drawbacks to this approach. Firstly, it is quite render heavy because Mocha is doing the heavy lifting. The second one is more of license availability. So if you plan to hand off this setup to another artist, make sure he's got Mocha installed, otherwise he won't be able to process this mat. So that's something to keep in mind. So far we covered 2 approaches getting your mats out of Mocha: rendering an image sequence and utilizing the mat output of the Mocha Pro plugin. Both have the big advantage that they precisely deliver what you intended to get when you created your rotor inside of Mocha. But both have also drawbacks. Rendering out the image as a sequence means that the rotor is pretty much baked, and if you find that you need to make adjustments, you constantly have to switch back into Mocha. Also, you always have to think of supplying the image sequence if you plan to hand off your sequence to another artist. With large shots and resolutions, these can easily become large file sizes. Utilizing the mat output of the plugin remedies that somewhat, because the project file size is only a couple of kilobytes. But it has the big drawback that it needs a Mocha license, so handing off the project to another vendor might become an issue. Also, with both approaches, you're not really able to adjust your rotor in context with your comp. So these problems can easily be solved by exporting the shape data in a way that your host application can understand. Luckily, Mocha comes with a plethora of export presets. However, as with every translation, not everything translates perfectly in every direction. So let's see what gets carried over and what gets lost on the way. So as I said earlier in the class, I want us to take a look at how to import these into After Effects, Nuke, and Flame respectively. And I thought about the best way to do this because there are many ways you can create shapes, modify shapes, utilize shapes inside of Mocha. So I thought instead of using our motorbike driver, I'd create this little comparison chart here with all the various ways that shapes can work. So we've got an X-spline, which is the most commonly used, actually the only one we used on the driver. Then we've got a Bezier. So just to illustrate that, if I click on the X-spline, you see that's the typical X-spline circle as in comparison to the Bezier circle with its Bezier handles. Then we've got a new kind of shape, which is an open spline. We haven't really used this before. If you ever want to use it, it's pretty easy. Just pick up an X-spline, start creating a shape. And when you're finished and want to keep it open, just hold down Shift and press your right mouse button or pen button, and then you've got an open shape. And these can be really useful if you, for example, want to rotor hair. So let me delete that. So we've got an open spline here. Then here we've got the square set to a subtract mode so that we can see whether mat intersection and subtraction from other mat works correctly. Then this guy here has got really exaggerated motion blur. So I'll zoom in here and set this to the correct views so that we can see that. Let's pick motion blur, and there you can see the motion blur at the various stages, so it's a little bit bigger there. And last but not least, we've got the edge softness on this one, and I also animated that to see if the animation gets carried over. In addition to that, most shapes have got animation on its spline as well as an overall animation. So if we take a look at the X spline once more, you see that it slowly drifts from the left to the right, as does the Bezier, so that we can see if all these get translated over. The way I'm going to do this is that I'm going to timestamp the various segments. I'm going to do one segment on After Effects, one on Nuke, one on Flame, and if only one is of interest to you, then please just go ahead and jump to that sequence, and hopefully after that I'll see you for the conclusion of the class. All right, let's start off by exporting to After Effects. And let me preface this with that exporting from the standalone version of Mocha to After Effects, in my humble opinion, is not the way to go. And I'll illustrate to you why. So down here, we hit Export Shape. We want to transfer all visible layers, and we want to pick Mocha shape data for After Effects. So we copy that to our clipboard and switch over to After Effects. So in After Effects, I make sure that I'm on the first frame, and I'll add a solid to my composition like that and paste that data from Mocha. So now you can see my shapes got carried over, and if I scroll through this, I can see that my animation got carried over, my blend mode got carried over correctly. However, my open spline doesn't work that well, and most importantly, I haven't got any shape data I can manipulate. So in that regard, it's not really that helpful. So let's explore that a little bit closer. I'm gonna open up that panel here, and there we see each of our splines applied as an effect. So what we can do is we can, for example, get into the sub square here and change that blend mode to an add. So we've got some control of our shapes, but the main one that we want when we export as metadata rather than a rendered sequence is not available to us. We can't really get to that shape data and manipulate our shapes after the fact. So let's explore how we can do that. For this transfer to properly work, you need Mocha Pro inside of After Effects. Luckily, if you own the standalone version, you also have access to all the plugin versions of Mocha Pro. So that's not a problem. So what we're going to do is we're going to go up to the Effects panel, and from there we're going to select Mocha Pro. And that way Mocha Pro gets applied as an effect. So we're going to launch that, because what we need to do first is to bring our project data from the standalone version into the After Effects version. And that's really easy. You just go up to the File menu, choose Merge Project, and then you navigate to your standalone Mocha project, open that up, and now you've got all these shapes available here. From there on, we can just close our Mocha UI like that. We're going to save it. And now in the Met sub-menu, you've got Create After Effects Masks. So you hit that, and there you go. The only thing that is not quite right now is right now they are applied to our background. We want to apply them to a solid. So let me just once again create a solid up here like that. I'm going to select the masks, cut them, and paste them into my layer. And now you can see all our shapes applied here. If we expand our solid, we see now they're applied as masks instead of shapes. So let's analyze this a little bit more. You can see that this process converted our X-spline. Our X-spline in moca had 8 vertices. This one has got much more. However, I can tell you the shape is exactly the same. The Bezier, on the other hand, really comes along with its 4 vertices and its handles like we expected from moca. The open spline, as that was based on an X-spline, is converted as well. The subtraction on our square works just nice. Let's zoom in on the motion blur a little bit. So I'm gonna bring this to 400%, pen down here, and that hasn't got any motion blur on it. That is because the motion blur in After Effects is layer based instead of shape based like it is in moca. So if you want to apply motion blur, you have to switch that on. So you can select that mask, go up to layer, mask, motion blur on, and you will get a motion blur. However, you will not get the motion blur amount you set up in moca. So you'll have to adjust that in After Effects. Let's explore the edge softness. So that one really doesn't translate too well either. So to summarize in the end, most of the important data gets along. We get modifiable shapes that we can treat inside of After Effects after the fact. The only things to be really aware of are motion blur and edge softness. So if you intend to work with open shapes, be aware to make these kinds of adjustments inside of After Effects rather than inside of moca. So this is what our motorbike driver rotor would look like in After Effects. So we got all the shapes. However, our color coding is replaced by a very random color choice of After Effects. And if we pop this open, we'll see that we haven't got our folder structure anymore. So those are things to keep in mind. Other than that, the rotor works nicely and we can still manipulate each and every shape. And as we illustrated before, motion blur sadly doesn't get translated as well, but you can apply it inside here of After Effects. So next up on our menu is Nuke. So if we hit the Export Shape button and pop this open, we see we've got a total of 5 flavors we can export, and we're gonna step through those one by one. Everything you export are basically .nuke files. So if you save them away, you'll get a small nuke script containing your rotor, but you can also copy to the clipboard, which is the way we're gonna go. So the first 2 options are basically legacy options where the tracking and the shape data are saved directly on the shape, which is a little bit data heavy in comparison to the Nuke version 6.2 plus roto and roto panes you can export, where the tracking and the shape data are saved separately. The result is the same. Those are a little bit less data heavy, and at the time of this recording, the current release is Nuke 13.0, so I think we're safe to work with anything above 6.2. So that leaves us 2 options. So you can either export a roto node or a roto paint node, and your choice may depend on how you want to work with the shapes further once you go into Nuke. I'm going to select the roto node and copy that to my clipboard. And once again, I make myself aware if I want to export the selected layers, the visible layers, or all the layers. So I copy that to the clipboard and I'll see you in Nuke. So inside of Nuke, I'm just going to paste my roto node, and here you go. The first thing to mention is the name is always the name of the shape that you selected in moca. So if I head back to moca, and you see this is the first shape I selected when making this multi-selection. So that's the name I get when I paste my node into Nuke. So if I hook this up here just for a second to see what we get, there you go. So if we hit this open, we see we get all our shapes. We can select those. Once again, as Nuke's residential shapes are Beziers, our X-splines get converted. So we've got a lot more vertices on our X-spline in comparison to the Bezier, which translates like we expect with just 4 points and the handles. The open spline gets converted. However, there are a couple of drawbacks. The main one being that we really can't influence the thickness of the shape. Even if we export a roto paint node, which gives us the ability to adjust the stroke, those options are grayed out. Let me show you. So I'm just going to select the open spline, export that shape as a roto paint, copy that to my clipboard, head back to Nuke, paste that in, take a look. So there's my spline. If I go to the stroke, those are all grayed out. And if I can't adjust that, I really can't make this usable to me. So one use I can imagine is exporting these to a spline warper. But in regards to roto, sadly, the open splines are somewhat limited. So let's get back to our original export. I'm going to delete this. So the subtraction inside of Nuke is not made by the color, but instead by the blend mode. So if you take a look here in this column, you see the blend modes of your various shapes. So if you take a look, this one is set to an over and this one is set to a minus. But if you want to change it, you can easily do that like that. I'm going to set that back to a minus. Let's take a look if motion blur got translated. So Nuke, like Mocha, has got a shape-based motion blur. However, as you can see by default, if we scroll up here, the motion blur is switched off. If I switch it on, nothing happens. So as you can see, you have to set up your motion blur manually inside of Nuke. Last but not least, let's explore the edge softness. So as you can see, the animation of our edge softness got translated. However, from here on, it's a little bit hard to manipulate as you have to adjust each of these individual handles, but it is possible. So here we got the roto of our biker, and as you can see, our color coding got translated correctly. That is really neat. As to be expected, no motion blur, we checked that out. But what we don't get is our folder structure. Instead, Nuke decides to create a folder for each individual spline. So the name we've given a spline moves to the folder, and inside that folder is an actual spline with a number. So that's a little bit of getting used to, but other than that, this works quite nice and leaves you a lot of opportunity to modify your shapes inside of your comp. Last but not least in our little export selection is Flame. So with Flame, there are a couple of things you need to be aware of. Firstly, if we select the open spline and choose to export the shape, we actually get a warning. The selected format does not support open splines. And this is to be taken quite seriously because actually, if you choose to export to the Flame Tracer presets, Mocha might crash on you. So before we do anything, I'm gonna deselect our open spline and just export those shapes and bring up back the export shape dialog. So we've got three possibilities. We've got the Flame Gmask script. Now that's the legacy Gmask inside of Flame. I personally don't use that for a long time now, but it is there if that still fits your workflow. Then we've got the Flame Tracer basic setup. So that will export Gmask tracer shapes. And those are compatible with Action and Image and all the current tools. With the basic setup, you just get the shapes without any axis. And if you've got loads of tracking data applied to it, then you can use the shape and axis where the tracking data is going to be applied to the axis and you've got separate control over the shape. So if you select the Gmask, you can actually copy that to the clipboard. However, you can't do that with a tracer, either with the basic or the shape and axis. So you'll have to save those out and load them inside of Flame. So in Flame, Let's start with the legacy Gmask. So I'm gonna load that up here, hook that to our comparison chart, and load our export. And Flame asks me to align at the first frame, so I'll do that. And if we scroll through this, we see a lot of things working right. And actually, with the legacy Gmask, you can try to export an open spline. However, Flame will close it up for you as it hasn't got a concept of an open spline. So you'll end up with something like that. Other than that, no surprises here. Our X-splines get converted into Beziers with a lot more vertices, while the Bezier itself gets exported as we expected with exactly the same number of points. One thing that doesn't really get propagated through properly, though, are the blend modes, as the shapes inside of the Gmask don't really have a concept of blend mode. Those are interpreted all as white, and you'll have to adjust the color manually, and you'll have to be aware that these values are keyframed, so adjust them with auto key on, or just delete the keyframe and then set the color to 0. And now it works as expected. The motion blur doesn't translate at all. You have to set that up on your own in the Gmask. But what does get translated is the edge softness. But as this X-spline is converted into a Bezier, you'll end up with a lot of handles. So moving away from the legacy Gmask, we pull up the Gmask tracer and we'll start with the basic setup. We'll load that up here. And if we switch to our result view, you see I excluded the open shape, as that would have had Mocha crash on me. And other than that, no big surprises here. All X-splines get converted into Beziers. The Bezier itself translates well. Even though the new Gmask tracer has got a concept of blend modes for its shape, all these get imported with white. So like with the legacy Gmask, you'll have to adjust those. The motion blur, once again, doesn't get translated. And at least in this version of Flame, which is 2021.2, right now, the edge softness doesn't get translated to the Gmask tracer. If we look in the schematic, you can see all these neatly lined up. And as we've specified with the export, we've got no axis attached. Let's take a quick look at the keyframes. So as you can see here on the motion blur Gmask, which makes this kind of back and forth ping pong movement, we've got 3 keyframes, so that makes them easily modifiable. Let's replace this with a fresh Gmask tracer and load up our shape and axis export. And if we switch to the result view, this is exactly the same as with the basic export, so no surprises there. However, if we switch to the schematic, you'll see an axis attached to each one of those. And take a look at the keyframes. So those are baked keyframes. And actually, if we take a look at the values, those are all baked in at 0. So we'll take a look in a moment how that looks on a shape that has got a proper track on it. But for a rotor export like this doesn't make too much sense. So let's take a look at the motion blur, because that was the shape we looked at before. So on the shape, you've got the same 3 keyframes like with the basic export. So in this use case, the shape and axis export doesn't really benefit us that well. A couple of things to mention. As the Gmask tracer has got no concept of folders, but rather a schematic, we don't get any translation of our folder structure. We also don't get any color coding that we did inside of Mocha. So now let's take a look how the shape and axis export works on a shape that actually has got tracking data, and I quickly exported the track we did on his torso. Now keep in mind that was a pure track shape, so the shape itself hasn't got any movement, but just to illustrate the distinction between the both exports. Here we got the tracking shape, sits where it's supposed to be, and all the movement is applied on this axis. So you can use this in a couple of ways. You can parrot other objects to it. You could transfer this to an action or an image node, whatever suits your workflow. So let's take one more look how an export of our actual rotor would look like, because there are some things to consider when doing such a big rotor. So I'm gonna load up the whole rotor in one single shape. I did that as a basic export, so all the shapes are there. However, if I take a look, they are all arranged from top to bottom. So there's not much order to this, and this is something you want to consider when exporting. So what I did in this example, rather than setting up multiple outputs here and manually switching on and off all these Gmasks for the different outputs, I thought it's much more convenient to have a bike back like that. And then I'll pull up another Gmask tracer and load up the driver like that. And finally, for good measure, the bike front. So now I've got 3 outputs and I can post-process these with comp nodes or whatever suits your needs. So that concludes our discussion about MET exports. At this point, I really don't want to give a clear recommendation on which way to choose, because there are so many variables, like the way you work, the size of the facility, the type of shot, and many, many more. That's why I wanted to paint a detailed picture of all the export possibilities you have, with all the benefits and all the limitations. So you can experiment with these different workflows and choose the one that best fits your and your project's needs. So that's all I have for this class. In the next class, we'll tackle the final shot of this course, which will be a screen insert into a mobile phone, something that Mocha was basically made for. So I hope to see you then. If you've got any questions, hit me up on the FX PhD Slack channel. Until then, bye-bye.